Hello, my name is Carlos Garcia.
Hey, my name is Chouzhyk, and the article is GE Asset Management, Genworth Financial, and GE Insurance uses sequential linear programming algorithm to optimize portfolios, and we found that article in Interfaces. There are several reasons why we chose this specific article. We are MBA students with financial concentration, and we were looking for the article that would relate to the finance industry. And we will look specifically for the portfolio management company because we have taken those classes before. And I'm personally being involved in student investment fund, which is a $300,000 portfolio. I'm constantly looking for ways to beat the market. So I'm very interested in learning what optimization tools big and successful companies like GE Asset Management are using. Different companies use different approaches to get the highest yield possible. The goal of the GE Asset Management is to develop a novel sequential linear algorithm to optimize portfolios to maximize the expected returns. The decision variables are the expected returns of the portfolio and the number of assets in the portfolio and the weight of each asset. The portfolio optimization is a key component in portfolio management. The objective is to identify risk-return trade-offs of the portfolio by maximizing the return. The team formulated the portfolio optimization model using the variance of economic surplus as a measure of total risk. The economic surplus is the difference between the market values of assets and liabilities. This model is similar to the well-known Markowitz model, but with added constraints to match the duration and convexity of the assets and liabilities within an acceptable tolerance. The surplus variance is calculated based on a multi-factor risk framework rather than a cross-product of variances of individual asset returns and their correlations. The duration and convexity mismatches are the absolute values of the differences between the effective durations and convexities of the assets and liabilities in the portfolio respectively. And beneath the constraints, you can see the breakdown of the formulas, how those surplus variances and duration mismatches and convexity mismatches has been calculated. To illustrate the sequential linear programming algorithm, we show the feasible region of a two-asset portfolio optimization problem with three linear constraints. For this problem, the SLP algorithm begins by generating the portfolio that has the highest return by eliminating the risk constraint and solving the resulting linear program. The SLP algorithm constructs the efficient frontier with a sequence of portfolios starting with the portfolio that yields the highest possible return, and the SLP algorithm produces portfolios on the efficient frontier with decreasing risk and return values 2, 3, 4. Based on the individual portfolio strategy, there can be a number of constraints that could affect the performance of the portfolio. There may be a limit to how many asset holdings the portfolio may have. The credit quality is also a risk factor because the portfolio may be in default. The interest rate risk is also bears some effects, maybe some adverse effects. And the other one is allocations among different classes because the portfolio managers are always looking to way to diversify the risk, and they allocate their holdings into different classes like securities, derivatives, bonds. And the last two are effective duration, convexity, and capital gains. What are the difficulties for building and solving the optimization model for this problem?
So the first difficulty that we address is going to be measuring risk. So because risk is again represented by variance slash volatility, usually this is a non-linear measure. So this can present again a lot of difficulty when putting together this model. Also, another difficulty that we run into is developing the portfolio efficient frontier. So again, this is what we want the portfolios to land on this curve, which is again the efficient frontier. So again, portfolios that lie below the efficient frontier are going to be suboptimal because again, they do not provide enough return for the level of risk. And again, portfolios that are clustered to the right of the efficiency frontier are also suboptimal because they have a higher level of risk for the defined rate of return. So, and also I put trial and error because usually, again, developing this portfolio efficiency frontier, it's a lot of computation. Sometimes it's just trial and error, plugging in numbers. So that's something that also has to be addressed when building this model, how to efficiently get those portfolios to land as close or on the curve as possible. And also kind of an outside difficulty would be the actual framework and server capability when you're building this model. So with so much data and usage, you want to kind of, I guess, break and spread out the load across, again, maybe multiple servers and, for example, have a database specifically just for the data store. Also maybe web application just to help, as tools and different engines. So you want to again have stuff where everything is working again independently and spread out. So again, if you change or impact one server or function or framework, it doesn't affect the other ones. So that again is probably a difficulty that will have to be addressed when building this model. So some of the managerial impacts, though, of this model are it helps the managers be proactive. Again, proactive rather than just being strictly reactive. Also helps perform portfolio analytics much quicker, so that again you're better capable of responding. You are just aware of when something needs to be done, and again running this optimization model, and also helps you respond better to changing market conditions. Again, it's always good to be a step ahead. Not to, again, the whole being proactive versus reactive, having the capability of moving along and better responding to different market conditions, bull versus bear, different trends also. And also you have the capability of just analyzing more portfolios more frequently, because again, this application, this model helps speed up the process again, instead of doing this computation through hand or through Excel or something, or trying to do some linear equations and other functions. You have again this model that just prepares this stuff in minutes, seconds, versus stuff that takes hours and days. And then overall, just looking at some of the benefits, I mean, this type of model helps you get, again, the highest expected return for, again, a defined level risk, or again, putting the lowest risk if you're given a level of expected return. So again, that's landing that portfolio on the efficient frontier line curve. Also, again, benefits is you can invest in more security available in the market. So again, you're helping the economy by, instead of holding your money, you're investing more. And also, again, increasing value of the company and again, the client's portfolios that are managed, because again, through careful planning, through this, again, seeing what portfolio lands on that efficient frontier curve, and again, through diversification of your portfolio, you again will achieve the most optimized portfolio. Thank you.